All, welcome to the lecture series on two-port networks. This is an introductory lecture. Here we are going to discuss about some introduction of two-port networks, and also we'll discuss the things we are going to discuss in upcoming lectures. So basically, what is a two-port network? From the name itself, it is clear it has two ports. What's a port? Port is a pair of terminals. A pair of terminal is called a port. So we can say if it has two ports, it has four terminals. Can say this two-port network as a four-terminal network as well. We can draw this is a two-port network. It has four terminals. This pair of terminals are called a port. If we consider this as an input side, we can call it as an input port. Similarly, this is output port. Usually, we'll notate the input by port by 1 and 1 dash. Similarly, output port by 2 and 2 dash. So next question, what comes in our mind is why we are learning about two-port networks. The reason is many of the circuit what we are using in our electronics engineering, communication, all these applications are two-port networks. Examples are filters, attenuators, equalizers, even the transistor which we learn, we can model it as a two-port network. So in all these situations, if we want to interconnect two network elements, or if we want to connect a source to the network, or if we want to connect a load to a network, to design it properly, to connect it properly, we have to understand the electrical properties of these two-port networks. There's a reason why we are going to learn about this two-port network. Next question, what comes in our mind is what we are going to learn here in this two-port network analysis. Basically, if we know if it is like discrete components like capacitor, inductor, or any other components, we'll be learning about some properties of this. If we learn that properties, we can use that properties in the network analysis of circuit which contains these elements. Same logic applicable here. If it is a resistor, if you know the resistance value and the wattage rating, you can use these two information to design a circuit with this resistor and to analyze a circuit with already this resistor present. Similarly, if we know the electrical properties of a two-port network, basically what are the electrical properties of a two-port network, which is usually described by using some parameters. We know for discrete components, we'll be using some parameters like resistance, wattage rating. Similarly, here also we'll be using some parameters. There are different parameters to describe the electrical properties of this network. So we'll be studying about parameters, which is used to analyze two-port network, specifically Z parameters. Then we'll learn about Y parameters and ABCD parameters. Then H parameters, then G parameters. These are the most common 5 parameters which we use in network analysis. In upcoming lectures, we'll discuss about these parameters. Then next, we'll discuss about types of two-port networks. Most common classification of two-port network is symmetric and asymmetric. Symmetrical and asymmetrical two-port networks. Symmetrical or asymmetrical. This is one of the most common classification which is very useful in many applications. So symmetrical and asymmetrical. Asymmetrical network also called dissymmetric network. So these are the things what we are going to discuss. When we are discussing about symmetric and asymmetric network, there are some properties of a symmetric network and asymmetric networks. For symmetric network, we have the properties. One is characteristic impedance, second one is propagation constant. These are the two properties, very important properties of a symmetrical network. To analyze a symmetrical network, these two properties are very important. Similarly, for asymmetric network, sorry for that. Similarly, for asymmetric network, also there are some properties to describe this. One is image impedance, other one is iterative impedance, third one is image transfer constant. In this, we'll concentrate only on this two and these two. In upcoming lectures, expression for this as well we'll discuss, but in detail we'll discuss about characteristic impedance for symmetric network and propagation constant for symmetric network. And this is very important, characteristic impedance. Here as well, image impedance and iterative impedance. Hope it is clear what we are going to learn and why we are learning and what are the things you are going to learn in the upcoming lectures. Thank you all for watching. Bye bye.